everybody. I'm Manuel. I'm working at Centrifuge. I'm here from Berlin. And today I want to talk about smart contract development with dapp.tools. So because we were using dapp.tools, I think, for the last 8 months for all our smart contract development. And I want to basically give a general introduction to dapp.tools and our experience using a framework for smart contract development, which is not so widely known. So maybe a good first question is what's actually out there. Maybe you have an amazing idea, you want to develop some smart contracts, and there are actually a lot of tools you can use nowadays. For example, some people might know there is Remix, which is like this browser tool where you can easily create smart contracts from a web browser. I think the most well-known tool is Truffle. And there are also a bunch of other tools like OpenZeppelin is really cool for also if you want to have proxy contracts. And today I want to talk about dapp.tools. If you're curious, I also found a cool link from Consensus where they're just basically listing out all the available tools for smart contract development. But it's also not about development, but also about querying the blockchain, creating transactions. So what is actually dapp.tools and why actually we are really liking it? It's a command line friendly tools for smart contract development. And what I really like, so you don't need to use all of their tools. Maybe you only want to use a debugger, or maybe you only want to use seth, which is sort of their command line interface for creating transactions. And it was actually developed by dapp.hub. And there are some projects which are currently using it. I think the most famous one is maybe Maker with multi-collateral DAI, but also Chai was, for example, implemented, which is like this IRC20 tokens for DAI saving rates. And actually we are using it at Centrifuge for our Tinlake smart contract developments. And I put here like the link on GitHub. And actually what I really like, dapp.tools are inspired by the Unix philosophy. Maybe some of you already know, and it's like back from the 70s where they have like actually really cool rules for writing programs, like write programs that only do one thing and do it well, or write programs that would actually work together, make it easy to write, to test, and to run programs. And that's, like, I think, a really cool philosophy because then you can sort of just use certain parts of this framework. For example, if you only want to debug or you only want to use certain things. And it's also really cool. Maybe you can check it out. There's a bunch of videos on YouTube about the Unix philosophy where they're talking in the 70s already about how you can actually pipeline all these nice command line tools together. So what are actually dapp.tools? So it's a bunch of tools. I already mentioned it. And there's like dapp, which is basically the tool for building, testing, debugging, and deploying Solidity smart contracts. And then there's like seth, which is sort of for querying transaction from the command line. And you can also, the really cool thing is you can also use it together with a ledger. So it's sort of like you can make a transaction with your ledger from command line, which is really cool. And they actually implemented their own implementation of the EVM in Haskell. And this is used, for example, for unit tests, and also it's used in the debugger. And actually, like, they implemented all the new EVM opcodes, so it's a fully general state compliant, and there's no problem if you're using it for testing all of your smart contracts. So maybe a quick background why we actually were choosing dapp.tools for developing our smart contracts. So quick background on Centrifuge. So we started out developing a peer-to-peer network, which basically allows to exchange documents on a peer-to-peer network, which was implemented in Golang and was using libp2p. And we just had some smart contracts for sort of anchoring document routes on Ethereum. And we also supported a way where you can basically tokenize documents. And then we were dealing with some NFT registries, but basically like 2 years ago, we only had like 2, 3, 4 contracts, and we just start using Truffle. But then we sort of and then we sort of ending up developing more smart contracts. And we were just like analyzing, okay, what's available, what tools are out there for developing smart contracts. And we were already aware of seth, which is this nice command line interface for interacting with the Ethereum blockchain. And like back in June last year, we're developing all our smart contracts with dapp.tools. And just to give you a rough overview, currently we have like between 3 or 4 devs working on our contracts, and our contract base is like around 20 modular contracts, and we also manage different deployments. So that's sort of the background on us. So how do we actually get started? If you're interested in playing around with dapp.tools, so you can just use curl, and it's using Nix in the background, which is a functional package manager, but it's straightforward to install. Yeah, I can wait for a picture. Yeah, and then so I'm just starting now with dapp, which is the tool, for example, if you just want to sort of develop your smart contracts. It's like super straightforward. You can just, for example, type dapp in it, and it will create like this project structure here, and it's nothing surprising in the end. It's like they're using some kind of lib folder for managing external dependencies. There's an output folder, which is storing all the AP files and the contract binaries, and then you have a source folder, and in the source folder you can also write your contract code and unit tests. Yeah, and here, for example, I just showed how a unit test looks like, and it's also, if you ever have written unit tests, it's super straightforward. It's like you have a general setup method, there's a one sort of base contract which you can use for testing, and then you can just write your tests with assertion as normally everybody's aware of. So it's super easy to get started using dapp for testing smart contracts. Yeah, so I will demo some stuff afterwards, but it's like, okay, you can easily execute, run all your tests, and what's actually is happening. So it's not like, if you maybe some people are familiar with Ganache, or previously it was called test RPC. It was always, you need to start it in the background, and it's using for most of the tests the JSON RPC interface for communicating. But this is like, if you just type dapp test, it spins up the EVM in the background. And what I really like, it's super fast compared with Ganache. Can show you after some benchmarks we did. So it's really, it makes really fun to develop the contracts and test them because it's super straightforward. Yeah, and for example, if you want, so let's say I have a nice IRC20 contract and I just want to deploy it with Seth. It's also super straightforward. So you can just type, okay, dapp create. Afterwards is the contract name, and then you can just pass the parameters in which the contract might need in the constructor. Okay. Yeah, and then also they have a really nice debugger, and they're also supporting log outputs, which is just basically using events, but you can really see it in the command line interface. And I have now, I think, a small example. Let's say it's just a little bit of code, but let's say we want to actually, I just wrote here a sample test. I'm using an IRC20 contract. Yeah, I'm setting up this IRC20 contract in the setup method, and then I'm basically minting on this test. I'm minting some IRC20 tokens. I'm using like here, this is one Ether. It's just called when you want to, because like normally IRC20 is using for the numbers 10 to the power of 18, and I'm actually minting one Ether or one of this currency token, and then I want to send it to Alice. And what you can see here, I'm actually making a mistake because I only have one, and I want to actually send two, so this test case will fail. And I can show you. I think I have it somewhere here. Yeah. So I can just run. See, oh, this test, so I currently just have one test, and this test is failing. It's just the code I was showing previously. And now I can just start the debugger. And I can see, so here in the first thing I need to basically, it's all in the command line interface. I need to select the test I want to debug, and currently I only have one test, so it's straightforward. And what I can do here, so now you can see a lot of stuff. It's actually all the EVM bytecode. What is really cool, but I can just jump, for example, here, step to the end, and then I can already see what's happened. Because I can see here, oh, actually this call was reverting because the insufficient balance. And I can really see here, okay, there was the error. The first thing was successful. It was just basically like this call for minting this one coin. And afterwards, I was calling this transfer from. So transfer from is the method for sending a transaction of an IRC20 method. And here you can see it was actually failing. And then you can also say, for example, I want to go some steps back. And I can really see, for example, here the stack, which is used. And I'm going to just go. It takes a while, but then I can see actually here's the IRC20 implementation. I use the IRC20 implementation from DAI. And here I can see here was this require check if I have enough balance. And sort of here it was failing. Yeah, and actually also it's super straightforward to install dependencies. Maybe you want to use other let's say you want to use Open Zeppelin or something, you can straightforward just use dapp install and it will install the dependencies in the background. Okay, yeah, maybe some background on our code base. So what we are basically doing is we wrote a bunch of smart contracts which allows basically that you can pool NFTs together. NFTs in our case are representing real world assets, and we're using these NFTs to basically, for example, get funding from Maker and multi-collateral DAI. And we're sort of internally pooling them to these NFTs together, and we're creating IRC20 contracts. And currently in our IRC20 an IRC20 token, and currently we have like about 200, roughly 220 tests in our code base, and we use like different tests. We use unit tests and also system tests. Like in the unit tests, we're using mock contracts, but currently our execution time is around 10, 13 seconds, depending on the machine, for executing all these tests, and this is way faster than, for example, with Ganache. I mean, yeah, and it's also a reason why it's faster, because we're writing all our tests in Solidity. Lots of projects maybe using just JavaScript tests to test for testing the functionality of their contracts, which is maybe straightforward if you already are a JavaScript developer, but it makes way more sense to write a lot of tests in Solidity, because it's also a way to getting a better Solidity developer, but just using the language more often. Because a lot of projects are ending up with just some small Solidity contracts, but it's a way, if you write a lot of tests, if you write a lot of mock contracts, it's getting easier, yeah, to get deeper into Solidity. And yeah, I actually also want to talk a little bit about deploying smart contracts. So what we are actually doing is we're using a contract factory pattern for deploying our smart contracts, because the really cool thing about that is that you can just actually deploy the bytecode of your contracts once. For example, if you're using it on mainnet, it's basically, if you're using a factory, the bytecode is only deployed once to mainnet, and then you don't need to pay that much gas if you redeploy the contracts, for example. And the idea is using this kind of factory pattern to just deploy your contract factory once, and afterwards you can just always call this factory again if you need a new instance of your contract. And it actually also allows, if you're using a factory, it allows nice coding patterns, like using this create2 opcode, which is a way that you can basically define, it's a new EVM opcode where you can basically define the address of your contract together with a salt, because previously it was just always using the nonce of your address, and this is basically a way that you can easily define the address in advance. Yeah, and what we're also doing is, let's say, we'll explain it afterwards a bit better, it's using also a deployer contract for deploying our contracts. This is basically a way to ensure that we're doing it in the right order, and that, for example, permissions are given correctly. Yeah, and then in the end, then we're sort of ending up, okay, we already have a deployer contract, but somebody needs to call the deployer contract, so the deployer contract needs to be deployed as well, and therefore we're using just seth, the command line interface. I can just show you roughly how it looks like we are using this pattern, and we adopted it from Maker, and we're using it currently in our code base, but the idea is maybe, let's say, you just have two contracts, contract A and contract B, and you sort of have some kind of dependency that you need to first deploy contract A, and it should be only, and contract B needs to deploy it afterwards. And what you can actually do, I'm just assuming already the factories are deployed, and then I'm creating like this deployer contract. I'm passing like the factories for this factory A and for this factory B, and maybe some additional params. And then I have like two methods for deploying like these contracts, because normally it's really expensive to deploy contracts if they're bigger, and that is a way that you can manage actually the gas. And it's first you call deploy A, and afterwards I'm calling here, and when you call deploy B, I'm checking if actually the first contract was already deployed. And if that's not the case, it would actually fail here, because here this is the reason why there's this require. So there's actually only one way how you can use this deployer. You always need to call deploy A first, and it's only possible afterwards to call deploy B. Any questions on that? Okay. Yeah, and now I just want to show you a bit what you can do with seth. So seth is super straightforward, as I already mentioned. The only thing what you need to do is you need to set at least two environment variables. One is like for the address you want to like to use, and the second one is you obviously need some Ethereum node in the background. It could be your local Geth node, or for example, you can just use Infura. And you can also use it with a ledger together. Yeah, and here, maybe I can also show this live. What I actually want to show live now is sending one DAI. If you want, I can also send me your address and I can send one DAI to you. This is my Twitter handle. We'll just check in 2 minutes. If your address is there, I will use that one. Afterwards, I just will show it with some example address. But first, so if you want to, for example, send one DAI from the command line, you need actually the IRC20 address of the DAI contract on mainnet. You can see here, you need just the type seth send, then you need actually the DAI contract, and then you need like, okay, which method I actually want to call on this IRC20, and there's one method called transfer from. We are basically providing the source and the destination and the amount you actually want to send. And afterwards, you just need to pass the from and the to address. The from address is actually in that case my own address, and then I just need some to address. And it's actually a bit tricky because this one DAI is actually not the number one. You need to be aware, like one DAI is 10 to the power of 18, and then you actually need to be aware that you need to do it in hex. But maybe I can just check if. Ah, yeah, okay. Okay, nobody. Okay, I will use just an example address. So what I'm first maybe showing here, you see, maybe I can make it a bit. It's a bit better, like that. Okay. I'm just showing here, this is like my environment file. I'm just using here a mainnet Infura link, and this is basically my address from my local Geth key store. And what I'm also setting here is the gas price. It's actually a bit quicker for sending this transaction. And I can just now source this file. And I can say seth chain for checking if I'm on mainnet. And then I can just say, okay, I have also some cheat sheet here for me for actually setting this amount to 1. This is like just the code I'm using for getting the hex code of 10 to the power of 18. You can send that. And here I'm just saying, okay, this is the DAI address on mainnet, and then I can just say seth send DAI. I'm defining now the method I want to call. From address. And I can just say from. Forgot this to close here. Yeah, obviously here in that case I need to enter my passphrase. Yeah. Now I can actually check. If it's there. Yeah. It might take a while because it's mainnet, but I'm just now sending the address. So I'm sending one DAI to myself. Where are my slides? But I think that's basically it from my side. And at Centrifuge, we're also currently hiring Rust engineer because we're building our own chain on Substrate with a bridge to Ethereum. So if you're a Rust developer or Rust engineer, please reach out afterwards. But I think I still have some time for questions in case somebody has a question. Yeah. Yeah, this is like for just checking, because I'm just using like an inferior link to check if I'm on mainnet, if I'm on RinkyB, or if I'm on a local Geth node. It's just for me a way to ensure, okay, is everything set correct? Yeah. Okay. Then thanks a lot.
All right, everyone.